All right, so thanks for coming this morning. Minghang and I are going to talk about how to go about perturbing the forcing fields in ACCESS OM2, and so I'll give a sort of an overview as to the facilities that are currently available in ACCESS OM2, have been for some time, and Minghang will talk about a new tool he's developed which will make it easier to produce large suites of perturbation experiments and manage them where you perturb the forcing. All right, so why are we interested in this? So there's been a lot of experiments with ACCESS OM2 where the forcing has been perturbed, and for example, adding meltwater around Antarctica, scaling up the zonal winds, changing the air temperature, and so on and so on. So these are kind of looking at, for example, climate change impacts on ocean circulation, for example. It can also be useful to perturb the forcing if there's some engineering reason for it. For example, there might be a storm which runs precariously or perilously close to the tripole and tends to cause instability. You can scale it down. So in general, these sorts of perturbations are scaling. So you have the original forcing field and you scale it up or scale it down by some factor, and or an offset. So you might be adding something. And those scalings and offsets might depend on space and or time. So to understand what's going on here, this is the ACCESS OM2 model architecture. It's got these three main components, and the component that handles the forcing is called YATM. And what that does is it looks at the model experiment date and it finds the correct netcdf file for the forcing corresponding to that date and extracts the correct variable from that and passes it on to CESS. CESS is actually where fluxes and things are calculated, and CESS will then pass various things on to MOM. And so the way YATM knows which forcing files to use for each of the forcing variables, so these variables here, such as the runoff, precipitation, air pressure, temperature, radiation, wind, it looks in this file in the atmosphere directory called forcing.json. And that file looks like this. It's probably a bit hard to read on the left, but I've pulled out one of these things and expanded it below. So it's a JSON file. It's a JSON format. It's a similar format to YAML, which you're probably more familiar with. And the main thing in it is an array denoted by square brackets called inputs. And the elements in the array are dictionaries denoted by curly brackets. And there's one dictionary for each forcing field. And so I've labeled the forcing fields here to make it a bit easier to understand what's going on. So these are all of the forcing fields that are passed into the model via YATM. Within each of those dictionaries, there's a keys and values. They are the file name, which says which netcdf file to get, and you can see it here for the zonal wind. You can see it's got this year in double curly brackets. Those are actually replaced by the actual year by YATM, so it actually finds the correct file. You don't need to know that detail. Then the field name is the variable name within that netcdf file corresponding to the variable you're dealing with. Okay, so UAS is the zonal wind variable in this JRA55 input file. CNAME is the coupler name. Don't worry about it. Don't change it. But there's another name you need there. And one thing, and the thing I'm going to talk about today is this optional array that you can add called perturbations. Right. So if you wanted to modify the forcing, there's an obvious way to do it, but it's also a hard way, and that is to make a copy of all of the relevant netcdf files that you want to change them, then modify forcing.json to point to those files and run your model. Okay, and a lot of people have done that over the years, but it's not ideal for a number of reasons. It might involve a very large amount of data processing and storage. So IAF data is 3 hourly. It runs over 60 years. If you want to modify all of that, it's quite a lot of data to process and also to store. It's kind of awkward. So for example, if you've got a model run that's using RYF forcing, you've only got 12 months of forcing there, but maybe you want to have a perturbation that ramps in over 20 years. And to do that, you need to produce multiple sets of perturbed forcing for each of those 20 years, and it's just painful. It's kind of inflexible. If you want to do an ensemble of perturbation experiments, you've got to go through this whole process over and over again for each of the perturbations you want to do. And it also lacks provenance. So it's not clear to somebody looking at your experiment exactly how the input files were perturbed, because you have to look at the perturbed input file and sort of do a difference with the original to work that out. So the better way is to use this online perturbation generation facility we have in ACCESS OM2, and that calculates the perturbation while the model runs. And it does this by combining the unaltered input files. It might be JRA55DO or ERA5 or whatever you're using. It combines it with additional perturbation files that you supply. And this is specified by that perturbations array I mentioned in forcing.json. So by doing this, you have a clear record of what you've done, and you don't need to mess around with the original input files. What does that look like? Well, I've again shown forcing.json on the left here, and I've just narrowed it down to one input field, which is this one here. And so this one happens to be the downgoing shortwave radiation field. And now I've added a perturbations key and value in here to show you what that can look like. Now, so the perturbations is another array. So you've got an array containing dictionaries containing arrays, and the elements of that array are dictionaries, okay? And there can be as many of those dictionaries as you want, and each one has a bunch of keys and values in it. So they have a type, which might be a scaling, an offset, or a separable type, which I'll explain. It has a dimension, which specifies whether it's constant in space and time, or temporal, that is constant in space but varying only in time. Spatial, which is kind of the opposite, constant in time but only varying in space, or spatiotemporal, which is a full space-time variation. Okay, so you have to have one of those if you're using scaling or offset. The separable, it's actually this, you have to give it an array that looks like this. So as you said, it's temporal and spatial. That's just what's required. All right, so that, and then there's a value field in each of these. And what you put there depends on what you've chosen for your dimension. Okay, so if it's constant, all it requires is a number. So if you just want to, double the downgoing shortwave for some reason, you can make a scaling where that number is 2. It's as simple as that. If you've got a temporal, so all the other options for dimension require a netcdf file or files. If you're using temporal, that netcdf file has to contain a one-dimensional variable, depends only on time. As you'd expect, spatial requires a 2D variable depending on x and y. Spatiotemporal requires a 3D x, y, and time-dependent variable. The separable case requires 2, and so those are specified as paths. So you can see here there's a path to a netcdf file. So that just contains the perturbation that will be combined with the original forcing. For separable, you have 2 paths. So you have a path to the temporal component and a path to the spatial component. So each of these netcdf files requires a variable in it, which has the same name as the variable in the netcdf, in the JRA55 netcdf file that you're trying to modify. Okay, so it needs to have a variable which is the same as in this case as which is RSDS in this case if you're doing shortwave. Okay, so that's the variable name. Also, that variable has to have the same dimension names and dimension order as this field in the original file. And if you've got a time-dependent perturbation, maybe spatiotemporal or just temporal, you only need to define data for the collection of times that you actually want to modify it. So if you're doing a spatiotemporal variation over, just a month, you only need a month's worth of perturbation data. All right, so that's the value one, and this is where kind of all the work is really, because this is where you need to set up perturbation files. And you can do that in any way you like, and you can see it's very flexible because you can have an arbitrary 2D, 1D, 3D array going in there as your perturbation, is whatever you want. The other things you need to specify here are calendar. I'll explain what that means later. And there's a comment that's required, and you may as well use it to explain things to yourself and other people. Laurie, you got a question?
Yeah, sorry, just one clarification. Maybe I missed it at the top. So here you have the GR55, you're going to have a list of forcing, and it's within that list that you can add the perturbation. So you could potentially add perturbation to several fields at once. Is that?
Absolutely. Yeah. Any or all of them can be altered in any way you like. And each of those alterations are independent and can have any number of components. So it's very general. In practice, people will most likely not need to use all of this complexity, but it's there if you ever want it. Vilma.
Yes, hi, thank you. So for this case that when the forcing should, for example, like ramp up over time, what approach would you suggest is best then?
What's the spatial structure of the forcing?
Well, I'm just making something up here, but I don't know, let's say everywhere the temperature should increase.
Everywhere? Then you'd use a temporal.
But then you... So I guess I'm trying to figure out how this is better than changing the actual forcing file.
Because you only need a one-dimensional variable. So if it's spatially uniform, you only need a 1D field, which is far less data and easy to generate.
Okay, and then I add like different timestamps.
Yeah.
And with that, I get like a change between.
Yeah, whatever change you like. Yeah.
And then it's only
it's explained when I have more in the next slide.
Spatially and temporally different changes. Then I need like a 3D file, I guess.
Maybe. Yeah, I'll explain it more so that it might be separable, which I'll explain in the next slide. Is there another question? Is it Hannah?
Yeah, I had a question, but it's very similar to Vilma's, and perhaps you're going to explain it on the next slide. So I'll just wait and ask it if it doesn't get covered.
Yeah, because it kind of does beg the question, well, how does all this get combined? So that's the next slide. Okay, so as I said, you can have multiple scalings. So you can have several scalings, and you can have several offsets, and you can have several separable offsets for each perturbation. That's more than you probably want. But so for each field that you're perturbing, the model does this at runtime. It gets the original. Can people see my cursor? My arrow? Yeah. So it gets the original field. It multiplies all of the scalings for that particular time, and it multiplies that product by the original field. Okay. And then it gets all of the offsets and adds them up and adds that into the whole thing, and also some of the separable ones. And I'll explain what separable means just in a moment. So all of these ones here, each of these things can have whatever spatial temporal structure you want. And as I said, they require an etcdf file or a constant, and they're picked up at the correct time based on the calendar that you've chosen. Okay, so the system works that out for you. So mathematically speaking, the dimension spatiotemporal option, that covers everything you could possibly want to do, right? Because you can do an arbitrary spatiotemporal variation. The trouble is it requires three-dimensional data. So then you're back, if you want to do something that across 60 years of JRA55, you're back to the same situation of having to provide the same sort of volume of data. as if you just modified the input files. So that's not really much of a help. It's most useful only if you've got just a temporally limited spatiotemporal change. So that's why we have the other dimension options. So oftentimes the forcing, the perturbation you're trying to apply actually has some simplifications you can make use of. All right. So if it is constant in time, you only needed to supply one number. It wouldn't make sense to have a three-dimensional X, Y, T field containing, just one number added to everything. Or it might be spatially uniform, just depending on time. So it's a one-dimensional vector, a one-dimensional array, or spatially variable but independent of time. So that's only two-dimensional data. And the other one is separable, which I'll explain now. So this is, it's a product of a temporal field and a spatial field. So it's like this. This is sort of mathematical terminology for a field that has this sort of structure, right? So you can see this actually also requires much less data than a fully arbitrary three-dimensional field, okay? Because you just need a one-dimensional and a two-dimensional data set rather than having something that has as much data as the product of those two things. Right, so oftentimes that's quite a useful, that applies to actually quite a lot of useful cases. So if you want to have a perturbation, which is say a sum of EOFs, each of those EOF components is a time series and a spatial map, and you multiply them together. And so if you have multiple separable perturbations, you can have an EOF reconstruction with multiple EOFs. And you can have complex EOFs where you have those, different phase components and so on, or you can do it for Fourier sums. Okay, so that's potentially quite a useful way of approaching things. So that's basically it. That's how it's all done. And so you can see that basically it's a linear function. You have your input, and you've got a coefficient at the front and an offset. And the coefficient and the offset are spatiotemporally arbitrary. So that covers many use cases, hopefully. Any questions on that?
Yeah, I have a quick question still. Can you hear me fine?
Yeah.
So yeah, this is really cool. Thanks, Andrew. I'm just thinking about situations in which this might not work. And as far as I can tell, that might be where your spatially varying forcing is not ramping like linearly in time or according to some like 1D function. Like let's say if you want to take the output of CNIP6 models or something and not ramp from the forcing to some future time, but actually take that time varying forcing. This doesn't apply to that case, does it?
Yeah, it does. Yeah, I just use ramp as an example. So what you supply is a one-dimensional array, which has a value for every 3-hourly time step that you want to modify. And it's whatever value you like. So 3-hourly for J array or 1-hourly for era 5. Does that make sense? So it's
but if you have a spatially varying forcing and the value in each grid cell is not varying from one time step to the next time step at the same rate that the value in an adjacent grid cell is varying, how do you represent that temporal component without having the full field?
Yeah, it depends if it's something like an EOF, then it's already separable and you've got that simplification. If you've just got some arbitrary time varying two-dimensional field, you have to use spatiotemporal.
And you still need a file for every time step, or
every time step you want to not model time step, forcing time step.
Yeah. Okay.
Yeah.
But if you can decompose your temporal variation into some 1D function, then you can use this process.
Yeah. I mean, it's most useful for kind of idealized perturbations. So if you've got, some spatially varying scaling of the winds in the Southern Ocean, or something like
Yeah.
that, where it just depends on latitude or something, then it's, yeah, it's kind of engineered for that kind of thing.
Okay. Thank you.
Yeah. So it's not necessarily, so if you've resorted to using spatiotemporal over the whole time set data set, it's not really giving much value.
But it does
other than
more clearly separate your forcing perturbation from the original forcing.
yeah. So it gives that sort of provenance of exactly what you've done. Yeah. Okay.
So can I just quickly then ask again? So let's say for the case where when we would want to change the winds over the Southern Ocean. So then I would give a temporal function to however I want to change it. And then for the spatial, I would kind of give the mask.
Yeah.
Is that then the role of like ones over the Southern Ocean and zeros elsewhere?
Yep, if you want to do it with that spatial structure, yeah. Or it could be like a half sinusoid over the Southern Ocean or something a bit smoother or whatever you want.
Okay.
Yeah. All right. So then the question is which calendar to use. So as I said, you can choose between experiment and forcing calendar. So the thing to understand here is that there's actually kind of two calendars in ACCESS OM2. There's the one you're used to thinking about, which is the experiment calendar, which is just the model date. It's where you're up to. So if you've got, say, an RYF experiment that you start at 1900 and you run to 2000, it's just the year that you have in that range. But then there's the forcing calendar. So these are the dates that are actually in the forcing files that you're using as the model runs. So in RYF, it's actually looping over this 12-month lump of data over and over again. So there's a calendar associated with that. And so your perturbation can be based on either of those. All right. So if you want to do something like ramp up a perturbation in some way over 20 years with an RYF experiment, then you want to use the experiment calendar to do that. Whereas if you want to do something in the same way each forcing cycle, so in RYF, if you want to perturb some particular spot at some particular time in the same way each cycle, you should use the calendar forcing. That's basically what that means. One last thing, you can get some unexpected consequences here and there. If you're perturbing air temperature without also perturbing the specific humidity, that will alter the relative humidity, which will change the latent heat flux. So you need to be careful about things like that. But you can force the model using relative humidity instead to avoid that. Just in case anyone was thinking about doing that. And I'll just leave it there. There is a bit more information on this on the ACCESS OM2 wiki, which I'll try to update this afternoon because it's a little bit less clear than it could be. And that's the QR code if you want to go to that. And then I'll hand on to Minghang unless anybody's got any more questions. Nice. Thanks,
I
Andrew.
have one question. Are there examples of how these files best look like?
Yeah. So if you follow that link, you'll find some example scripts that generate files. Yeah.
Okay, cool.
So thanks, Andrew, for walking us through the science reasons for perturbing the forcing fields. Now let's just look at the practical side. How do we actually set up and run these perturbations in ACCESS OM2 without losing our sanity? So the current solution, in this section, I'm going to take advantage of one example from Ryan Holmes. This one is from ACCESS. This one is basically the ACCESS OM2 forcing perturbation Jupyter Notebook tutorial. It's a very simple case, but it's also very clear and intuitive, especially the kind of the workflow researchers typically use when running the sensitivity tests or the ensemble experiments. Yeah. So in this example, basically, it's going to modify the zonal winds, which is a UAS in the tropical Pacific region, and the perturbation is basically time-independent scaling. Perturbation is basically 1.25 times the zonal winds in the tropical Pacific region. To get started, so basically, to run a control experiment or the control simulation, a user should just change to a directory, like an arbitrary directory here, and clone the repo from GitHub to your Gadi directory, and then check out a new branch and cd to this configuration, and using the Payu workflow to run the simulation. And then the second step is to set up the perturbation simulation configuration. So basically the same thing for the first step, which is to clone the same repository from GitHub to a local directory with a different name, and then just cd into this directory and then check out with a new branch name. And then the next thing is we're going to do the perturbations now. So basically we want to find appropriate file name or the field name from this atmosphere forcing.json file. So basically this is one example from the forcing.json file. So as we're going to modify the zonal wind, the UAS, so we're going to search from this list and where is the UAS is. And then after finding those, we can just insert a perturbation blocks into this JSON format. Because since we're doing a scaling perturbation, so the type is scaling and is time independent, so the dimension will be spatial, just basically the 2D two-dimensional spatial field. And the value here is the one that I generated externally, also following Ryan Holmes' notebook. And the calendar is forcing, and there is a common, which is time-independent increase in tropical Pacific zone of zonal field, or the zonal winds. And after doing this, the second step would be to make the archive directory and copy the restart output from the control experiment. So this is like the same approach, like shown in Ryan Holmes' notebook. Is just one way to handle the restart paths. But Payu, as Payu is evolving quickly, and now even it supports the keywords in the configuration file to manage, the restart links automatically. But I'm just showing the many methods here because in practice, there's still how like many research work, like just copying and linking the files by hand. It may feel a bit messy, but it just reflects the typical workflow that most of us are still using today. And then finally, we can run the simulation, which is following the similar process from the control experiment, just cd into this control directory and using Payu workflow to run the simulation. So as you can see, like even for this very simple perturbation run, the traditional workflow is a little bit messy, and you have to go through the multiple steps, like cloning the repository, copying files, manually, editing the different configuration files, and sometimes you have to change multiple parameters in different configuration files as well. So this makes the process a little bit repetitive and error-prone and difficult to keep track of. So it's easy to make mistakes. What if? So now, what if instead of like juggling copies and edits, you could just write down your changes once, and then the Gadi or the computer can create the branches for you, and then what if it also just managed a job submission for you? So this comes to this this Python suite. So the first one is the ACCESS experiment generator, and the second one is the experiment runner. So basically, this is the ACCESS experiment generator. You just write down a YAML file like this. Instead of making copies by hand, it just creates, the Git branches, one for control and one for the perturbations. And each branch has the right parameters already applied, and every change is tracked by Git. So it's transparent and reproducible. So then after creating this YAML file, you can just run this simple command, experiment generator -i, which is to accept the input YAML file. So this one is just called the generator om2 forcing.yaml. And after this step, you can have both the control branch and the perturbation branches. At the second one, or the second step, is the experiment runner. So once the branches exist, the runner manages the runs. You just tell it which branches to run. So for example, in this case, that we have running branches control and perturb 1, and how many runs each should have. So in this case, that for the control is 2, for the perturb 1 is 1, and where to start from. So the code, which means it's starting from scratch, and this one, the control / restart 0, which means it start from the control branch, the first restart file. And then I can handle the PBS job submission in Gadi using Payu under the hood. And it also detects already completed or failed runs and make sure the jobs are not the same. Yeah. Yeah, so that's basically the introduction of this tool. Any questions so far? So after that, I'll just show you more details from the website.
I think I have a question. Thank you. So I guess often we run experiments with an idea what you want to do, and then realize, one experiment didn't work, or we want to change it, or for some reason one experiment didn't work, didn't run. So in that case, would you then suggest to still use this file, assuming I just then want to run one particular experiment, and only include the one experiment in here?
Your question is if
let's say I run 10 experiments, the control, and then 10 perturbations, and one of the perturbations for some reason didn't work.
Yep.
So I want to rerun this one perturbation.
So your question is, want to rerun this perturbation, or you don't want to run this specific field perturbation?
No, if I need to rerun this one perturbation.
Yeah, so you can just set the end runs here and with the specific running branches that you want to. Because for example, if the branch is filled for some reasons, you can just check into the branch and diagnose the reasons for that and fix it. And then you can still using this experiment runner to run this branch as well. Yes.
Okay, thank you.
Yep.
Can I just ask, so n runs here, does that specify the number of successfully completed runs?
Yes, you're right. Yes, the number
of... not the number of submissions. So it'll keep doing runs until it's got n runs successfully completed.
Yes, all right. Thanks, Andrew. Yeah, that's what the code intended to do. Yeah. So any more questions? So this is the experiment generator. So just make it, there you go. So it's under the ACCESS-NRI organization project. So basically, so you can check out in the README, it just introduced some of the features, like the key features and what the tool is about. And also, we also provide a full documentation is available at this link. So if you just click on this link, you can see some similar like the introduction, like why doing perturbations and key features, and also some quick guide. So in this quick guide, so basically if you're running cases on Gadi, you can just use like this module use, this week83 pre-release module and module load the Payu development version. So which means that our current tool has been implemented into the Payu development content environment, so you don't need to install it manually. You could, so just load the module. Just load the Payu development module. You can just run the experiment generator or the runner by itself. I've seen something on the chat. Okay, thanks, Chris. And then the second one is getting started. So basically, you have 3 different options to install it on Gadi. As I just mentioned, the tool is installed in the Payu development content environment. So you can just loading the Payu development module, and then you can use it directly, or you can create a virtual environment and then just install it from pip. And the third option would be if you want to contribute to the code, you can set up a development environment and then just install it via the pip install -e, which means that you don't need to install it every time once you make a change. And for the usage, it's quite simple. And so the tool only requires a single YAML experiment plan, where I have also 3 I also have 3 examples provided under the same repo. So if you just click on this link, you just go into these 3 examples under the ACCESS experiment generator. Yeah, so in this example, so I'm just coming back to this. I will go through these examples in later soon. Yeah, okay. Okay, so and also provide a quick start. So just create a minimum YAML file and just save it as a experiment generator.yaml, and you can just run the generator with that. In this one, I didn't make any edits to the control experiment, so which means you will get a control branch without any edits. But for the perturbation experiment, I have 2 branches. So after running this command, you're going to have perturb1 and perturb2 branches with the parameter values committed. And then for the next page, I also provide some YAML guide just to explain the keyword, like in this YAML configuration file. And also something about the control experiment edits, and also the perturbation experiment edits as well. So I'm going to take one example to show you side by side and explain this to you to help to quickly understand what these terminologies mean. So the first entry in this YAML file would be the model type. For this specific case, I'm using the ACCESS OM2. Currently, it supports the models ACCESS OM2, OM3, ESM 1.5, and ESM 1.6 at the moment. And the second entry would be the repository URL, which is the remote GitHub URL. And the start point would be the commit hash for the new branches. So basically, this commit hash is for the control experiment. You can also specify the branch here as well. But here, I just specified the commit hash here. And the test path here is like it just houses all the control and perturbation experiment right there. And then we have the repository directory is the local directory name for the central repository. So for example, like if we have already created these lines, and what we'll have first would be, let's just jump to the code. So we have a test path is called the prototype -0.1.0. So in this folder, after running the experiment generator, then we got this prototype this directory. Just ignore these three directories because I haven't generated them now. And then after doing that, we're going to have a repository directory, which is called the 1 degree GRE55 RYF configuration in this case. So this is kind of like the repository directory, which is the control and the perturbations will be forked from this directory. And then this comes to the next one is the control experiment. I specify 3 different files to make a change. So if you follow the guide here, I also have the same or the explanations for this file as well. So in many cases that you might want your control branch to have some modifications. For example, you want to change a few default parameters. So, but if you don't want to change anything, just leave the key control experiment there. All right. And this example is right the same one as I just shown there. So for example, if we want to adjust the run length and the job queue for all experiments, so we can just set up exact same one from this. This is from the ACCESS OM2.NML. So we have the restart period just changing from the default 5 years to now it's only for 1 day. And the similar thing for the Payu configuration.yaml, we change the queue from normal to express and change the wall time to 5 hours for this case. And just some notes here. As you can see that in the following, the config.yaml and the i/size_in.nl. So these file paths are relative to the repository directory, which is the the ice_in.nml is a file under this repository directory of the size subdirectory. So the YAML hierarchy must mirror the structure of the file inside of these cases. So after doing this, all these steps, so we're going to create a control experiment just after running the command line. So if we're just coming back to, it's like changing to the directories of that and using the git branch. So you're going to see a control branch right there, just aside from the main. Is there any questions so far? I've seen some chat box. Yeah, and then for the second one is for the perturbation experiment. It's the core part for this tool. So basically, we can describe one or more sets of experiments and parameter changes for those. And for this specific example, like we have 2 branches, like the perturb1 and perturb2. And for each configuration file, we can change the specific parameter inside of those. So in this case, I'm changing the alb ICE and the 0.0 and the 0.06 is for perturb1 and the 0.07 for perturb2. And similar thing for the ocean input fortune nameless file as well. And just breaking down this structure, so we have the parameter block 1 is an arbitrary name for this group of experiments. So you can choose a meaningful name as for your case. And also we can have multiple parameter blocks. So now we only have one parameter block 1. You can also just put another one right to the bottom, like the parameter block 2 or 3 or any others, whatever. So inside of each parameter block, you can have you should have these the branch key, which is it's a special key, and it must name as the branches under the block. So you can list the branches that you want to do the perturbations. And the other keys under the parameter block would be the file names, which is exactly following the same structure from the control experiment. So it just keep the relative path for each file. So for the eyes, for the size in, and for the input.nml is from the eyes and the ocean as well. Yeah, so after that, the generator will iterate through each branch and apply the corresponding value. So each branch is just created from control experiment, and the value from that branch index applied to the files. And you can also go through some rules to using this tool. I'm not going, because of the time limit, I'm not going to going through all these details. And after that, I still have another section which is called the Perturbation Cookbook. So basically, it just tells you additional tips and examples for writing these YAML configuration for some complex cases. It just covers how to format like the YAML file and how this tool interprets the inputs to assign values to each experiment. Because of the time limit, I'm not going to cover all these things. But in most of the cases, I think the current tool covers most of the structures, but not covering all the configuration files at the moment. So for example, let's go back to this tool, and under this repo, we have a GitHub issue here. So this is coming from, so now we have an inventory of the configuration files that requires the parsers and updater support. So basically with the green check, which means that these file or the file format is supported in the current tool. So basically it supports the YAML file, the Fortune name list, and the mom input for from the OM3, and the NUOPC files from ACCESS OM2 as well, and the forcing JSON file as Andrew just mentioned in his presentation. It also supports this file as well. But for the rest of those, the field table or the data table are currently not supported at the moment, but we are going to import these parsers and updaters in the near future, I think. Yeah, just give you some hint on this as well. And then the second thing would be the experiment runner. So let's see, it's still under the ACCESS-NRI organization. So this experiment runner, which follows the similar command line tool. So basically, this package is also installed in the Payu dev environment. So you can just module load the Payu dev environment. You can just use this tool without installing by yourself. And the usage is also similar. So you just provide a input file. So basically just experiment -runner and -i, and then with a YAML input file for this as well. And one example is provided in the example folder as well. So you can see we provide a test path which is similar to the one in the generator tool, but instead of a relative one, you have to specify a absolute path for this test path. And similarly for the repository directory, the same, and the running branches is also coming from this as well. So in this case that we have the control branch and two perturbations called the perturb1 and perturb2, and similar things for the running branches here as well. Okay, and then just as I said from the previous example, like you can specify the number of runs for each branch, and it must match the order of the running branches. And the starting point for each branch, there are currently two options. So one is the code is starting from scratch, And the other option is starting from a specific control run or a specific perturbation run with the restart index. So for example, like if you started from the control, the first restart of the control, you just name it the CTRL dash the restart 000. And there are some other explanations for each key in this YAML file, and also provide some workflow examples there. I think we're running out of time at the moment. I think we just stop here.
Ask if you had a use case where you've done a suite of perturbations and you wanted to add a new one, would you just, so you need to add it to the perturbations sort of YAML file to specify what you want to change, and then add it to the runner, and right,
Yeah.
and then if you run the runner, it will only do the new one.
So one use case is like, for example, you created 2 perturbations first, and then you run the runner for these 2 perturbations, and then you have a third one or fourth perturbations. You can still use the generator to create the third and fourth perturbation branches and use the runner, just adding the running branches, just extending this list with the perturb3 and the perturb4, and similar thing in runs as well. So you can just continue. Yeah.
So those YAML files end up actually being like a log that records exactly what you did in terms of your, that's quite useful.
Yeah, that's right. Yeah. Yes, Chris.
Thanks, Minghang. Super cool. Just a small thing. What is the difference, actually pretty much where your cursor is, between control and perturb restart? Because isn't like perturb could do the job in both cases, maybe?
It depends on the use case. So for example, for the perturb2, you don't want to restart from the control experiment, but restart from perturb1. You can just specify, I have a use case here, actually. Can quickly show you.
Oh, I think I follow. Okay. So, but it knows that it needs to run perturb1 before it can do perturb2 then?
Run perturb1 first.
Oh, because that's clever.
To generate some, yes, right, to generate some restart file, and then you can run the perturb2 based on the perturb1 restart file. So in this case that I've run the control, I think a better example could be in this example. So this is kind of like the use case. So initially I would just set the n runs for the control run is 2, and for the rest of 2 are 0. And starting point, hang on, and just starting from the code, because it's 0, so for the perturb1 and perturb2, they are not running. Only the control run is running. And after the above, there will be 2 archive output and restart directories created in the control run, for example, like this. And suppose we now want the perturb1 to start from the first restart of the control, and perturb2 is to start from the second, and then set the n runs for the perturb1 and perturb2 to 2. And then after running this, and for the start from restart, for the perturb1 is control restart 0, and for the second perturb is restart from 1. So after running this in the perturb1, you're going to have something like this, and the restart 0 is coming from the control experiment. And similarly, in the perturb2, it's restarting from the second restart directory and following 2 additional runs. So that would be the restart 2 and restart 3 with the output 2 and 3. Does it make sense?
Yeah, I think so. Yeah, thank you. Yeah, it's just helpful to sort of see some of these workflows.